Well, hey there, everyone. Welcome to part 4 of the Carrie Furnaces YouTube tour. And today we're going to discuss the ore bridge. And there's no better way to look at the ore bridge than to... So here we are up on top of the ore bridge. There's a great view of number 6 furnace. And we are, I don't know, 100 and some feet off the ground on the ore bridge structure itself. Now, first off, I want to let you know, everything that you're going to see up here on this structure is not a part of the tour when you come here. This area is not some place that you can go to see on your own. So if you're seeing it, you're going to see it in this video or any other videos that we produce. But you know, for everyone's safety, we can't let people up on these structures like I'm doing here. So at any rate, we got that out of the way. Let's talk a little bit about how an ore bridge works, what it does, and its part in the iron making process. So as we've talked before about the ore yard and the big field down there that has the stockpiles of iron ore in it, and we also talked about the car dumper, and the car dumper is right over there. So the transfer car would bring the ore out into the ore yard, dump it into a pit. There would have been a pit right here, and then this thing, basically a big gantry crane, would come out with that bucket right there and pick the ore up out of the pit and then bring it out and then drop it in this area right here. So you'd have ore piled up 50, 60, 70 feet up in the air. It'd be a pretty big pile, depending on what time of year and how much material they have on hand. That's why this thing sits so high, so it can clear that pile. And it would stockpile the ore in this yard. It would have iron ore. You'd also have some limestone here. And if you had different grades of ore, you might have a couple of different piles that were separated. Sometimes they'd make a tie wall or just kind of have just two piles there. That you could separate the different types of ore. And the other function of the ore bridge would be to then also take ore out of the pile and then bring it over to the high line to go into the furnace. And as you can see down there, you can see that bin. So that bin is where the ore bridge operator would dump the iron ore into that bin, and it would sit in that bin until a transfer car came down and picked it up. But we'll go over the bin later when we get down there. What I want to talk about right now is what's up at the very top. So you have the bridge structure here, and you have a leg on that side, and then you have a set of legs on this side. This isn't a rigid structure. If you could see right there, there is a pivot. That's a bearing. So the legs could rotate a little bit in relationship to the bridge. So this thing could kind of skew itself a little bit, and if you wouldn't want it rigid, because you'd have a chance of having a lot of problems with tracking. So in order for it to track up and down its tracks, it needed to have that little bit of flexibility. Each side had drive motors that were tied together, and everything was operated out of the control pulpit over on the trolley. Now what we're looking at right here, this contraption, you see you got a pretty big cylinder there, another one here tied together with a beam going across. This is basically just a snubber at the end of track. So if the trolley came over here a little bit too fast, instead of just hitting hard stops and putting a tremendous shock load on the bridge, it would hit these snubbers and it would slowly, would slow it down to a stop. And then what you had in here is there's a piston in there and a spring, and then there's oil. And then once you hit it, the oil flows from one side of the piston to the other side. And there's orifices in there that control how fast that happens. And so you can control you know, how much retardation force it gets as it's slowing it down. All right, so let's take a little walk out here onto the bridge itself. All right. There's another place I haven't been in a few years. I used to do a lot of volunteer work down here in 2010, 2011, 2012. And then I was working so much on the Todd engine and the J&L 58 that it'd been a couple years I had not been down on site at all. But now that we're working on the 48 mil project, I'm down here several days a week. All right. So down there, it's a top view of the car dumper. Oh boy, I forgot just how high this was. I don't really like high places. That's why I see hand is firmly on the railing at all times. You know, but that's how you get to be 50 years old and not dead, is by taking precautions and doing things nice and easy. All right. So here is the top of the trolley, and nice wheels. It is. So you had drive motors. That's a hoist motor for the drum. You got several of those, and you had the drums here for the ore bucket. And then down over here was another drive motor, and of course it had springs and a suspension system. And you can see at the other end also had that snubber at that end as well, because I guess the last thing you want to do is for this to end up in the river. All right, so now I'm down here on the trolley itself, and you know, this here is a load brake, so can't really make anything out on that. But one very important part when you're dealing with anything like this, electrically driven, is that when you turn the power off, you want whatever it is you're driving to stop. So you'd have load brakes, especially for the hoist, that would bring it to a stop. So you had a big drum, and then you had some shoes, and then this here is an electromagnet in there and a spring, and it had springs in there would naturally keep it closed. The electromagnet, when you put power to the motor, would resist the spring and open up and allow things to move. So these are all very important. They're fail-safe. So in our videos, you're going to see a lot of these. You'll see a lot of this setup with a typical mill motor, with a drum and a brake. Then also you'll see a lot of gearboxes with a pinion coming out and a gear reduction and all that. Pretty typical. Every steel mill, you're going to see a lot of electrical gear like this. All right, let's take a look. Aha! Now here's a great view of the ore yard itself. So there on the left, there's that car retarder, and over here is the high line with the 3 tracks on it. The innermost track towards us is one normally for coke, but if you were bringing iron ore in and you wanted to go right into the ore yard and bypass the dumper, you could just bottom dump out of the cars right there, and that was set far enough over the wall where it would just drop right down into the ore yard. So you could avoid using a car dumper. The middle track was for anything coming in, going to the bins. Like if you wanted iron ore to go right to the bins, you could go in the middle track. Limestone, scrap, anything that you wanted to go right in the bins went down the middle track. And the one to the far right was the track for the transfer car, which went from the bin at the bottom of the ore bridge out here and dumped into the bins. So originally this here was cut off like that. Later on there was a ramp that was added so that you could at least get up on, I think the middle track, and of course that was all taken out when a lot of the demolition happened on site. Of course, at one time you would have had lots of tracks back in there, full of hopper cars of material. There was a ladle house that was back over in there, and a filter plant, some buildings that were there as well. On the other side of that little bridge, the B&O had a stub-ended yard for delivering materials to Carrie furnaces and to Homestead in general, because the B&O main line was on the other side of the P&LE. And then here, a little better view, you can see that standpipe or water tower, and to the right of it is the river pump house I talked about in the last video. All right, so yeah, up here you could see there's a central pivot for that leg as well, and there's also a little hoist there, so if you're doing any work on the trolley, you could do it in here. And of course, you got a little roof on there, so you wouldn't have to work outside. This is generally where you would park the trolley when the ore bridge was not in use, to keep it under the roof. All right, let's see here. So this is a good place to talk a little bit about the furnace, or the furnace structures itself, where you get a good view of them. The three large tank-looking structures are stoves for heating the air blast up from the ambient temperature up to the 15 to 1700 degrees that you needed to go into the base of the furnace. There's some additional equipment down here on some platforms, and of course you got the high line, and then to the right here is the dust catcher, and on the other side has a dust catcher. And then when we go over the exhaust gas system for the furnaces, I'll go over what a dust catcher is, what a gas washer is, what a gas dryer is, what an electrostatic precipitator is. I'll go over all that later on. But for right now, this is just a great way to get an overall view of it. So you look at this bridge, and it's painted this pinkish red, and you also look at the car dumpers, also painted red. And the interesting thing is that this was painted after they shut the furnaces down. There's places around here where you can see the red paint on tops of the rails, signifying that they never ran this after they did the paint job. So we don't know why it was that they did that, but it must have been some U.S. Steel program where they went all around, the furnaces in the Mon Valley, painting all the ore bridges. And maybe at that point they had figured at some point they were going to fire these back up, so might as well put the investment into the paint job. We greatly appreciate that U.S. Steel did that, because that's the newest paint job of anything around here. So we don't have to worry too much about the corrosion on the ore bridge right now, because it does have a decent paint job. All right, so I'm going to shut the camera off and walk across the bridge here. Then I'll meet up with you again as we're going down to look at that hopper. All right, so we're down here looking at this hopper. So as I mentioned before, the bucket would come over here and then dump into this and store some material for the transfer car. As a matter of fact, there is some of the spilled iron ore still sitting up on top of the apron there, and that apron would go over this side as well. So those buckets leaked, especially the taconite pellets. You'd always leak some out of it. So in order to protect whoever or whatever was down on the high line, you'd have this protecting apron here. And here we are down underneath of that hopper, and you can see down here there is the motor that drives the mechanism that opens and closes the gates, the doors, lets the iron ore down into the transfer car. And again, your typical arrangement of mill motor, brake, gearbox. And so over here, as we talked about before. So you had your transfer card track, the hopper card track for materials coming in, and then you had the bins for the Coke. So that bin right there is for Coke. And this other bin back here was for something called Coke Breeze. So Coke, being a very light and friable material, broke up rather easily, and you didn't want all those fines in the furnace. So there were screens, Coke screens down under here, and any of the fines would then get dumped by a conveyor into this box, and the bucket would fit in that box, so it could then just come in there and pull out the fines and then load them into a rail car or whatever. The Coke fines, otherwise known as Coke Breeze, was used in steel making for various purposes, so it was a valuable commodity. So that would be taken out to be used elsewhere. All right, so then there's, look down here, you have another drive motor and a gearbox. I believe that was for the clamp drive. Remember we talked about in an earlier video about the clamps that were on the other leg. So that's the drive for the clamps on this side. And then you also had the drive motors and all that. So if you'll notice on these bridges that one leg here of this is pretty big. There's it comes down to a V, but there's a lot more structural up here to it, and the other one is pretty skinny. I believe they called that the shear leg, and I forget what they call this side. But they were all built this way, and it was for stability reasons. So all right, and finally we're down here underneath on the high line. There is the bin and that platform we were just on, and then looking up to where we were at when the video started, and then you can see the drives and all that at this side, and then across, and then a good look over on this side. So I was going to go down into the pulpit, but these steps are a little treacherous, so I decided against it. What is it? It's been 10 years, and I'm 50 years old now, and I'm not quite as adventurous as I used to be. Back then, I'd climb all over all this place here, and nothing would bother me, and now I'm like, I don't know. So, all right, well, that brings the end of this this installment here. And well, I just noticed something. That isn't for it. That's not a drive for the clamp. I see cables running up. I wonder what that is for. I don't know. I'm going to have to look into it and see. I don't really know what that is. I don't want to tell you stuff that's not true. So, all right, at any rate, it's getting cold out here. My hands are getting cold, so I'm going to go back inside, and I will talk with you next time. In the next installment, we're going to talk about the stockhouse trestle, what this is, and what part it played in the iron making process. All right, everyone, take care.